Hello students, today we are going to start with our third chapter of electric generation and economics. So this chapter is the title for this chapter is power plant economics, and the main contents which we have to cover under this chapter are the first one is the capital cost of plants, that what is the cost that related to the installation of the plant. Okay, what is the fixed cost or what is the cost of land or what is the cost of whole machinery. So all that comes under the capital cost of plant. Next is the annual fixed cost. Annual means yearly. Okay? Yearly fixed cost. And under this also comes the different taxes, insurance, depreciation that must remain fixed for each and every type of the power plant. Okay, and it depends upon the type of power plant, whether it is a hydro or nuclear or thermal, like this. And next is the operating cost, and under operating cost we have to cover all the consumable products related cost. Okay, so which main includes the cost of fuel, or you say the cost of maintenance, repair. Okay, the cost of other consumable products like lubricating oil, diesel, all that comes under the operating cost. Okay, next one is the effect of load factor on the cost of energy. Yes, how the variation in the load factor affects the cost of energy, or what happens if the load factor is more, okay, or if the load factor is less. Yeah, how if the load varies on the power plant, changes continuously, then how it affects the cost of energy. All that we have to cover in this topic. And one final very important topic is the depreciation. So depreciation, this word relates with the depreciation of any machinery that is installed in the power plant. Like if there is any machinery like turbines are there, generators are there, okay, boilers are there, and the continuous depreciation with the passing years is there for any type of machinery, and it requires maintenance, it requires repair, and for that maintenance and repair we have to spend some extra cost on them. Okay, so all that factors, all that cost comes under this topic, depreciation. And in this we have to cover definition of the depreciation, then the different types of depreciation, then some derivations are there, formulas are there. Okay, so all in one, that this chapter relates with the cost. Okay, as the last chapter relates with the load, so this chapter relates with the cost, fixed cost, operating cost, depreciation cost, and all that. Now starting with the generation cost of power plants. Yes, and the generation cost, generation means any related to any power plant like thermal power plant or hydropower plant, that what is the generation cost, and it depends upon these main three factors. One is the fixed cost, other is the operating cost, or you say running cost, and one is the investor profit. Okay, that means this generation cost must include its expenses in the form of fixed cost and operating cost, and also there must be some profit to the industry. Okay, so it includes mainly these three factors: fixed cost, operating cost, and investor profit. Now the capital cost of plants. The capital cost of plant includes the preliminary cost, okay, which includes the cost of land on which it is planned to install the power plant, okay, and other real estate. So generally we see that all the power plants are installed far away from the city. So one reason for that is that there the cost of land is less. Okay, if the power plant is installed near the city or within the city, then the cost of land is very much high. So one factor to install the power plant or to locate the power plant away from the city is to consider the cost of the land, because the cost of land is less. Next is the cost of design and planning. Okay, before installing any power plant, all the architectural work must be required to done. okay, which includes the cost of designing that which machinery is at which place, or proper planning of the power plant is there. Okay, next is the cost of building and equipments. Okay, the building cost, all the civil work is there. Okay, and equipment that must be ordered from the other manufacturers. Okay, like boilers, turbines, the big manufacturers are like BHEL. Okay, so the cost of building and equipment is there. Then the cost of transportation is there. So while the building and equipment must be bring to the required area, there must be proper transportation facilities be there. Okay, and the lots of expenses be there for the transportation facilities. And next is the erection and installation of the equipment and overheads, etc. Okay, so this all includes the capital cost of the plant. And one thing, in case of hydroelectric power plants, we know that for hydroelectric power plants, a very large uh, area is required for river purpose, for reservoir, for dam. So in comparison to the other power plants like thermal or nuclear or gas turbine, so in comparison to these power plants, large area is required for the hydroelectric power plants. So in case of hydroelectric power plants, the capital cost of the plant also includes the cost of dam, which is the extra cost. Okay, earthwork, that is to construct the rivers accordingly. Okay, or to change the direction of rivers, to construct the reservoirs, excavation, railheads, highways, and other civil works. Lot of civil work is there for the hydroelectric power plant. And also compensation to the land owners whose land would be submerged in the reservoir. Okay, whose land comes under the area where the reservoir is to be planned. So the compensation is given to that landowners also. So this is all the additional cost for the hydroelectric power plants. Now next is the annual fixed cost of power plants. So under the annual fixed cost of the power plants, the costs which are independent of the number of units generated is known as the fixed cost of power plant. It consists of the following components. That means it does not depend upon the how many units are there in that particular power plant. Okay, whether there may be 2 units, whether there may be 4 units, or maybe 6 units. The annual fixed cost is the fixed one, that is the fixed expenses which comes yearly. And under this, the first category is the interest. The annual interest on the amount of capital investment. Okay, what the investment should be done to install the power plant. The annual interest on the amount of capital investment, like the land cost, building cost, equipment cost, installation cost, etc., borrowed from the banks or other financial institutions. Okay. Therefore, while calculating the cost of the production of electrical energy, the interest payable on the capital investment must be included. Okay. So the next point is the taxes. The utility may have to pay taxes to the government. Okay, that we all know that the payment of taxes to the government is there. Not that only the taxes which are a function of capital investment are included in the fixed cost. Okay. Insurance, a very well managed utility has to incur expenditure on the insurance against accidents. So each and every power plant or every type of power plant must be insured properly before its functioning. Okay, before its operating condition. Okay, and that insurance, why the insurance is required? So that if any accident occurs like fire, flood, explosion, or earthquakes, the proper compensation be given to the owner. Okay, so a very well managed utility has to incur expenditure on the insurance against accidents, fire, flood, explosion, earthquake, to equipments and personnel. Okay, and this insurance payment must be done yearly basis, on the yearly basis. Next is the depreciation cost. So the decrease in the value of the power plant equipments. So as we use any particular equipment, like say boiler, as we continue to use it for 10 years, 20 years, it needs some maintenance. It needs some repair also in between. Okay. So the decrease in the value of the power plant equipment and building due to the constant use is known as depreciation. Therefore, depreciation cost takes into account the deterioration of the component over a period of time. Okay, so this cost includes all the costs related to the maintenance and repair purpose for any that particular equipment. Next is the rate of return. So it is a profit on an investment over a period of time expressed as a proportion, okay, in a percentage base of the capital investment. That means what is the rate of return on the particular capital investment. The time period is typically a year, in which case the rate of return is referred to as the annual return. The certain rate of return should be taken into account in calculating the annual fixed cost. Okay, so all these parameters must be there under the annual fixed cost, and some others are like salaries of management and other officials. Okay, it is also almost fixed. Okay, it is also fixed, like a fixed salary is dispatched every month or every year. Okay, and next is the maintenance cost. A certain amount of supervision or maintenance is needed even when it is not producing any energy. Okay, some of the maintenance cost is fixed, like some regular repairs must be there on every equipment or machinery in the power plant, like some boilers or some generators are uh, have their regular maintenance after every month or after every 15 days. Okay, so on that some expenses must be there, and this maintenance cost is fixed annually. Okay, so these are all the various factors that can affect the annual fixed cost of any power plant: interest, taxes, insurance, depreciation cost, rate of return, salaries of management and other officials, and maintenance cost. Now next is the what is the formula to calculate the annual fixed cost. Okay, that we have to use in our numericals. So the formula for the annual fixed cost of ith unit here means like if you say that if any power plant has 4 units, then the annual fixed cost is calculated for each unit separately. Okay, here ith unit, let us suppose the annual fixed cost of second unit. Okay, then you say that, or the annual fixed cost of fourth unit. Okay, then this one is the fixed charge rate of the second unit capital cost of the second unit, and the capacity of the second unit. Okay, so what is FCR? FCR is the fixed charge rate of ith unit. Ith unit, which unit you are considering? The value of the fixed charge rate is fixed on the basis of above mentioned components of the fixed charge rate. And it is considered in the rupees per year, and you see is the unit capital cost of the ith unit. It is in the rupees per megawatt, and CI is the capacity of the ith unit in megawatt, and the overall units for this annual fixed cost is in the rupees. And if it is calculated on the yearly basis annually, then it is in the rupees per year. Okay, so this is the formula to calculate the annual fixed cost, that is the FCR multiplied by UC multiplied by C, fixed charge rate multiplied by unit capital cost multiplied by the capacity of that particular unit. Okay. Now the next main important part is the annual operating cost of the power plants. The operating cost means the all the expenses related to the daily or monthly variation as per its running condition, as per the running condition of the power plant. So In this, it is the cost which depends only upon the number of units generated, that how many units are in the working condition, not upon the how many units are installed on that particular power plant. So it depends upon the number of units generated that in the running condition. So annual operating cost consists of the following components. The first one is the fuel cost, the main component, the main operating component. The cost of the fuel includes not only its price at the site of the purchase, but its transportation and handling cost also. Okay. The fuel cost includes the cost of the fuel, its transportation, its handling. The cost of the fuel varies as the unit price of the fuel, that what is the cost of the fuel at its site location from where it is delivered. And next, the amount of energy produced. Next is the efficiency of the plant. It depends upon these factors. If your plant is highly efficient, then the less consumption of fuel is there. Okay, so the fuel consumption or the fuel cost of fuel indirectly depends upon the amount of the energy produced and also on the efficiency of the plant also. Next one is the labor cost. For the plant operation, the labor cost is another term of the operating cost. The maximum labor is needed in the thermal power plant using coal as a fuel. Okay. And one thing ki why this labor cost comes under this operating cost category, that in some of the power plants, the labor is not fixed. Okay. In some week, 2 units are in the working condition. Okay, or in some other week, all the 4 units are in the working condition. Okay, so when all the 4 units are in the working condition, more labor is required. Okay, and if the number of units are in the shutdown, then no labor is required or very less labor is required. So that's why the labor comes under this category of the operating cost. Whereas the salaries of the managerial or other officials, that is fixed annually, because that they cannot be hired as per the requirement or as per the running condition of the power plant. Okay, the running condition of the power plant, only labor cost affects. A hydraulic power plant or a diesel power plant of equal capacity requires a less number of persons. In case of the automatic power station, the cost of labor is also reduced. Okay, so as the automation in the power plant increases, the cost of labor decreases. Okay, the manual labor goes on decreasing. However, the labor cost cannot be completely eliminated even with fully automatic station, as they will still require some manpower for periodic inspections, etc. Okay, so but out of all the power plants, the thermal plant needs most labor as compared to the other power plant. Okay, maximum labor is required by the thermal power plants. The next one is the cost of maintenance and repairs. So in order to avoid the plant breakdowns, maintenance is necessary. And here you see that sometimes the maintenance or repairs may come by chance also. Okay, or due to some fault in any machinery, the maintenance is required, repair is required. Apart from the regular maintenance or from the monthly maintenance or monthly investigations. Okay, apart from these, some on the spot maintenance or repair is required if there is some fault in any type of machinery. So maintenance includes the periodic cleaning, greasing, adjustments, and overhauling of the equipment. The material used for maintenance is also charged under this head. Okay, sometimes an arbitrary percentage is assumed as a maintenance cost. Okay, like in some of the power plants, some amount is kept separate for the maintenance purpose only. Okay, some materials are kept separate for the maintenance only. Repairs are necessary when the plant breaks down or stops due to faults. Okay, if there is any fault occur by chance or some on the spot fault occurs due to the load variations, So then the repairs are required. The repairs may be minor, may be major, or periodic overhauls and are charged to the depreciation fund of the equipment. Okay, it depends upon the which type of repair is required. Sometimes some part is required to be replaced to any machinery. Okay, or sometimes there be some minor repairs are there. Okay. Next one is the supplies. The cost related to the consumable materials. Okay, this also comes under the operating cost. Consumable materials like lubricating oil and water for the makeup, cooling purposes and general use. Okay, this comes under the also comes under the operating cost category. Okay, so the operating cost includes mainly the fuel cost, then the labor cost, then cost of maintenance and repair, and supplies. Okay, these four categories generally comes under the operating cost. And now the formula for the numerical purpose, the calculation of the annual operating cost, and the annual operating cost of ith unit, its short form is AOC. Okay, for the ith unit is equal to FCI plus O&MI. Okay, what is FCI? So this is the annual fuel cost. Okay, FC means fuel cost. Okay, this is the annual fuel cost of ith unit. Okay, the fuel cost is calculated for each unit separately. Okay, sometimes in our coming chapters now we see that some of the units work more efficiently as compared to the other units. Okay, like this. So it is also further equal to the fuel consumed in kg per year multiplied by the fuel cost. Okay, so this is another formula, that how much fuel consumption is there, how much kilogram of the fuel consumption is there annually, and what is the cost of the fuel per kg. So this will gives you the annual fuel cost, or it is also equal to the fuel consumed in kg per kilowatt hour multiplied by the kilowatt hour per year. Okay, multiplied by fuel cost per kg. So this is another formula. Okay, you must note down these formulas for the numerical purpose. And O&MI means the annual cost of operating labor, maintenance, repair, taxes, supplies, the combined cost of all these factors. Okay, so one factor is including fuel cost and the other factor includes this combined cost. Okay, so FC is the fuel cost and O&MI is the other cost for the labor, maintenance, repair, taxes, supplies, for all that in terms of rupees per year. And together both these gives you the annual operating cost of ith unit. Okay, now some other formulas, like now once you calculate the annual fixed cost of ith unit and annual operating cost of ith unit, now this one is the annual plant cost of the ith unit. Okay, this is only for one unit. Like in some station there are 4 units. Once you have to calculate these for the one particular unit, then you go on the summation to calculate the net cost. Okay, so what is the annual plant cost? The annual plant cost for any particular unit is the annual sum of annual fixed cost and annual operating cost. Okay. Now next is the expected annual energy generated by the ith unit. That how much energy is generated by that particular unit and in the kilowatt hour per year. Okay, we know that the units of energy are kilowatt hour, and here we are calculating the energy annually, yearly basis, so that's why it is kilowatt hour per year. Okay, and it is energy generation is equal to the average annual load in kilowatt, that how much load is there on that particular unit, multiplied by 8760. So now what is this 8760? 8760 is the total number of hours in a year. Okay, total number of hours in a year. Like in a year, in one day we have 24 hours and 1 year include 365 days. So when you multiply 365 with 24, you got this numerical value, that is 8760. You must remind this. That is the number of hours in a year, 8760. And this one is further equal to the capacity factor multiplied by the plant capacity in kilowatt multiplied by 8760. Okay, so this is how to calculate the energy generated by the ith unit. Now, what is the generation cost of the ith unit? So, generation cost is annual plant cost divided by the energy generated. Okay, this annual plant cost when divided by the energy generated gives you the generation cost of the ith unit, and it comes under rupees per kilowatt hour, as rupees per year is the unit for this APC, and kilowatt hour per year is the unit for energy generated. So combining the unit for the generation cost is rupees per kilowatt hour by dividing the annual plant cost with energy. You must note down these formulas. Okay. Now, after doing this, after learning about the fixed cost, operating cost, now there is one comparison chart between them. So operating cost, you can also call it as a variable cost. Okay, because these all the factors that comes under the operating costs are continuously changing, varying. Okay. Like the first parameter is the annual fixed cost of the plant includes the interest, taxes, insurance, maintenance, depreciation, managerial, salary, rate of return, etc. And whereas the variable cost of the plant includes expenses which vary with the operation or the amount of energy produced. It depends upon how much energy is produced by that particular power plant. Okay, next point. The fixed cost of the steam plant consists of cost of land, installation, equipment, design, powerhouse, building, testing, commissioning, etc. Okay, whereas the variable cost of the steam power plant includes the cost of coal, oil, repair, water, salaries of the operating staff, or you say labor. Third point, the fixed cost of the hydro plant consists of the cost of survey, bridges, dam, earthwork, railhead, highways, other civil engineering works, powerhouse structure, design specifications, equipment, testings, commissioning, etc. Whereas the variable cost of the hydro plant includes the salaries, wages of the operating staff, maintenance staff, suppliers. The operating cost of the hydropower plant is very small, we all know, because the fuel that is mainly used in the hydro plant is the water, and that is naturally available. Okay, so the operating cost for the hydropower plant is minimum out of all the power plants. Okay, the cost for the operating cost for the hydropower plant is minimum because the water is freely available to us through the nature. Next is the fixed cost of the nuclear plant includes the cost of plant site, equipment testing, and commissioning. You can also add some more words, okay, that are related to this point or some other points. You can also add. The variable cost of the nuclear plant includes the cost of fuel, that is the uranium, okay, very much costly. Then water, materials required for the repair and maintenance, salaries and of operating and maintenance staff. The operating cost is very high. Why its operating cost is high? Because its fuel is very much costly. Okay, the fuel, that is the uranium, is very much costly as compared to the other power plants. Okay, so the hydro plant has the minimum operating cost, whereas the operating cost for the nuclear plant is high. Okay, so this is all about the fixed cost and variable costs. Now, before coming to one numerical, okay, now let's see this numerical. A generating station has a maximum demand of 50,000 kilowatt. Calculate the cost per unit generated from the following data, and the data that is given is capital cost is given, that is rupees 95 into 10 raised to power 6. This is the capital investment. Okay. Then annual load factor is given 40%. Annual cost of fuel and oil, that is rupees 9 into 10 raised to power 6. Then taxes, wages and salaries, it is rupees 7.5 into 10 raised to power 6. Then interest and depreciation is 12%. Okay. So in this numerical, we have to calculate the generating cost. Okay. Cost per unit generated. That means we have to calculate this one. Okay. Generating cost of the ith unit. Okay. So for this, we have to calculate firstly the annual plant cost. Then we have to calculate the energy. Okay. And how to calculate the annual plant cost? That is firstly calculated the fixed cost, then calculate the operating cost, and then you calculate the plant cost, and then after this calculate the generating cost. Okay, now see this numerical. Now the units generated per annum. How many units are generated, or how much is the energy generated yearly basis? So the formula is maximum demand multiplied by the load factor multiplied by the hours in a year. Okay, this is the formula of the load factor which we have taken in the last chapter. So we know that the load factor is equal to maximum demand divided by energy into time. Okay, time, that is in the hours. So here comes out to be energy generated per annum. It is equal to, what is the maximum demand that is given in the question? 50,000. 50,000 multiplied by load factor is also given 40%. You just write 0.4 multiplied by, and the number of hours in a year is 8760. Okay. So this is the energy consumption per year. Yearly basis energy consumption, 117.52 into 10 raised to power 7 kilowatt hour. Now the annual fixed charges. And under these, the annual fixed charges are interest and depreciation. This fuel cost and these salaries comes under this other operating cost. So annual fixed charges may aega, that is annual interest and depreciation, which is 12% of capital cost. Okay, here it is given 12%, and this 12% is on the capital cost. Okay, so it is can be further written as 0.12 for 12%, 0.12 multiplied by 95 into 10 raised to power 6. Okay, and you got 11.4 into 10 raised to power 6. This one is a fixed cost. And for the operating cost is annual cost of fuel and oil plus taxes, wages. That means the other maintenance and repair costs, salaries, all comes under this category. Okay, now the annual cost of fuel first. So which data is given? The annual cost of fuel and oil is rupees 9 into 10 raised to power 6. It is directly given here. Okay, no further calculations are required. It is directly given. But in some of the numericals, the fuel is given in kgs, and then its consumption is given. Then you have to multiply accordingly. But here it is directly given. So it comes out to be fuel cost is 9 into 10 raised to power 6. And other cost is 7.5 into 10 raised to power 6. So add both these costs and you got 16.5 into 10 raised to power 6. So this 16.5 into 10 raised to power 6 comes the operating cost, and this one comes with the fixed cost. Now the annual plant cost. The annual plant cost, it is a sum of fixed cost and the operating cost. Okay, so that means 11.4 into 10 raised to power 6 plus 16.5 into 10 raised to power 6. So the annual plant cost of the ith unit comes out to be 27.9 into 10 raised to power 6. Now, how to calculate the cost of per unit generator? So generation cost per unit comes to be this plant cost divided by energy. Okay, the plant cost is 27.9 into 10 raised to power 6 divided by energy is this one, 17.52 into 10 raised to power 7. And this will gives you 0.16, or you say 16 paisa. Okay, so this is the generation cost per unit. Okay, so this is the generation cost per unit. See one more numerical. Estimate the generating cost per kilowatt hour delivered from a generating station from the following data. And the data that is given is plant capacity is given 50 megawatt. Then annual load factor is given 40%. Then capital cost is given 1.2 crores. Then annual cost of wages, taxation, etc. That is rupees 4 lakh. Then cost of fuel, lubrication, maintenance, it is given 1.0 paisa per kilowatt hour generated. Now the fuel cost is not directly given. Okay, it is given in these terms, 1.0 paise per kilowatt hour generated. So what you have to do, to calculate the fuel cost, you have to multiply this factor with the total kilowatt hour generated. Okay, only then you got the total fuel cost. Okay, next, in our interest, that is 5% per annum, depreciation 6% per annum of initial cost. Now here in this numerical, interest and depreciation are given separately. Okay, so let's start. The maximum demand on the station may be assumed equal to the plant capacity, as no maximum demand is given in the question. So we can assume the maximum demand equal to the capacity of the plant, that is 50 megawatt. Okay, so in case the numericals, in some numericals, if the maximum demand is not given, but you need maximum demand for the energy calculations, so you can assume the maximum demand equal to the capacity of the plant. Okay, now calculating first the fixed cost. So for the fixed cost, the interest and depreciation. Interest is 5%, depreciation is 6% of what? Of this capital cost, that is 1.2 crores. Okay, you can also write it as 120 into 10 raised to power 5. Okay, or you can 1.2 into 10 raised to power 7. Okay, so it is 120 into 10 raised to power 5 multiplied by 5 plus 6 divided by 100. Okay, because it is in the percentage, or you simply multiply like 0.05 multiplied by 120 into 10 raised to power 5 plus 0.06 multiplied by this, or you can also do it like this. Okay, and by solving you got 13.2 multiplied by 10 raised to power 5. Okay, now here these wages and taxation, it also taken here in the fixed cost, and this comes to be 4 into 10 raised to power 5. It's directly given in the question, that is 4 into 10 raised to power 5. Now the total annual fixed cost comes out to be this plus this. Okay, so this is the total annual fixed cost, that is 17.2 into 10 raised to power 5. Okay, now comes to the annual running charges or annual operating cost or annual variable cost. You can call it by any name. Okay, so for this, firstly, here calculating the energy generated. So to calculate the energy or the units generated per annum, we are applying the same formula as done in the previous numerical. So maximum demand multiplied by load factor multiplied by hours in a year. So same formula as we have done here. Okay. So maximum demand, we can assume it as 50 megawatt, 15 to 10 raised to power 3 kilowatts. Okay, because we got the energy in kilowatt hour. So it is 15 to 10 raised to power 3 multiplied by load factor is 0.4. So it is given here 40%. Okay, so 0.4 multiplied by 8760. That is the number of hours in a year. So the energy generated comes out to be 1752 into 10 raised to power 5 kilowatt hour. Okay, now the cost of fuel, lubrication, etc. So for the cost of fuel, it is given here that 1.0 paisa per kilowatt hour generated. So what is the total cost of fuel? It is the 0.01. It is now in the rupees. Okay, we can write here 1 paisa as 0.01 rupees multiplied by the energy generated. So it comes out to be 17.52 into 10 raised to power 5. That is the cost of fuel. And so the total annual charges are, so it comes out to be That is the total annual charges mean the total annual plant cost. So fixed cost plus operating cost. The fixed cost is 17.2. Operating cost is 17.52 into 10 is per 5. So combining this will gives you 34.72. Now the generation cost, it is the annual plant cost divided by energy. The plant cost is 34.72 into 10 raised to power 5 divided by energy is 17.5, no, sorry, 1752 into 10 raised to power 5. So dividing this, you got 0.02 or 2 paise. Okay, so these type of numericals are there from these formulas related to the annual fixed cost or annual operating cost, then annual plant cost, then generation cost. Okay, so these type of numericals are there. Okay, so this next numerical, this is just for you, for your practice. And in this numerical, you have to compute the generation cost per kilowatt hour from the following data. That is the installed capacity is given, that is 120 megawatt. Capital cost is given, rupees 40,000 per kilowatt. Now see here, for calculating the net capital cost, you have to multiply it accordingly. So this capital cost is given as 40,000 per kilowatt. For 1 kilowatt, it is 40,000. And what is the total capital cost for 120 megawatt? You have to calculate that. Okay. Then upon that capital cost, you have to calculate further interest and depreciation. That is 15%. 15% of what? Of capital cost. Okay. Firstly, calculate the total capital cost. Then calculate the interest and depreciation. Okay. Next, fuel consumption is given. So it is 0.64 kg per kilowatt hour. Okay, 0.64. Firstly, you have to calculate the total consumption. Okay, so calculate the kilowatt hours first, that how much energy consumption is there, how much energy generation is there. Then calculate the total net fuel consumption. Then fuel cost is given as rupees 1500 per 1000 kg. Okay, 1500 per 1000 kg. Like for 1000 kg, the cost of fuel is 1500. Okay, so what is the total cost of fuel for the total consumption, which you are going to calculate in this step, consumption step. Okay, then other operating cost, it is given directly, like this 50 into 10 raised to power 6. Then peak load means the maximum demand. Okay, peak load maximum demand is given 100 megawatt and the load factor is given as 60%. So this is a numerical for your practice, or we have to going to cover in the next lecture. Okay, the next topic is depreciation, very important topic. And what is depreciation? So it is the decrease in the value of the power plant equipment and building due to the constant use. Is known as depreciation. Okay, let's see here, take one example of your motorbike. Okay, like in your motorbike, you have purchased that motorbike in 2016, say. Okay, and after 5 years, its cost reduces due to some maintenance purposes or due to some repair on it. Okay, what is the cost of that your motorbike in 2016 is not that cost in 2021. Okay, so that decrease in the cost of any machinery or any equipment is termed as the depreciation. Okay, so it is the decrease in the value of the power plant equipment and building due to the constant use, because we have used our motorbike on the constant daily purposes. So it's as its consumption increases, as its usage increases, its cost decreases. Okay, so that is the depreciation. From the time the power station is installed, its equipment steadily deteriorates due to the wear and tear, so that there is gradual reduction in the value of the plant. Okay, and this reduction in the value of the plant every year is known as annual depreciation. That how much the cost is decreased every year. Like In 2016, the cost of your motorbike is 50,000, say. But in 2017, it decreased to 45,000. And now in 2021, it decreased to 30,000, say. Okay. So this reduction in the cost of any machinery is the depreciation. Or the annual decrease in the cost is termed as the annual depreciation. Okay. And what are the factors that depend upon this depreciation is the continuous usage of that particular device or machinery or equipment. Okay. Therefore, a suitable amount must be set aside every year so that by the time the plant retires, the collected amount by way of depreciation equals the cost of replacement. Okay, like if I have to run my bike for 10 years, say, okay, and I kept aside each year some amount as my depreciation cost. Okay, and that amount after 10 years must be equal to the cost of the that equipment that is in the starting year, in the first year. Okay, so that by the time I retire my bike after 10 years, I can be able to buy the new one. Okay, so that is the depreciation amount. I'm again reading. So a suitable amount must be set aside every year so that by the time the plant retires, the collected amount by the way of depreciation equals the cost of replacement. Okay, so that we can replace that particular machinery. Like the cost of boiler, for boiler we can kept aside the depreciation, some depreciation amount every year. Like if the boiler, the net life of the boiler is say 30 years, so by the time the boiler retires, we can get that sufficient amount to replace that boiler with the new one. Okay, so this happens for each and every equipment in the power plant. So that is all in the this topic of depreciation. So it is the decrease in the value of the power plant, equipment and building due to the constant use, that is depreciation. Okay. Now, what are the different methods to find the annual depreciation charge? Like how much amount is required to keep aside? How should we know? Okay, so there are different methods to find the annual depreciation charges. Like the first method is straight line method. Next one is the sinking fund method. Next one is the fixed percentage method, or you also say this method as declining balance method or diminishing value method. Okay, so these are the three main methods to calculate the annual depreciation charges. Now, starting with the first method, that is the straight line method. Yes, for the straight line method, in this method, a constant depreciation charge is made every year on the basis of total depreciation and the useful life of the property. Okay, that means every year we kept aside some fixed constant amount. Like for every year we fixed 10,000 for any equipment. Okay, that is a fixed. Okay, but obviously annual depreciation charge will be equal to the total depreciation divided by the useful life. But here in this case that as we know that with the passing years, as the usage of that particular equipment increases or machinery increases, the more expenditure is there on its maintenance or repairs also. So as the life of the equipment increases, the more reserve accumulation is required and the depreciation is also required to be increased. Okay, so this is the graphical representation for the straight line method. Here, these are the straight lines. This one is the, so that's why it is called as the straight line method. And the formula for this is P minus S divided by N, where P is the initial cost of the equipment. S is the scrap or salvage value after the useful life of the equipment. Okay, and N is the useful life of the equipment in years. Like here again, if I am going to take the example of my motorbike, let the initial cost is 50,000. Okay, is the cost with which I can purchase the equipment or with the my motorbike. Okay, S is the salvage value or the scrap value, you say, after 10 years of my useful life of that machinery, of that equipment. Okay, like 30,000. I should resell it to somebody else. So that is the salvage value. That is the scrap value. Or N is the useful life with which I can use that particular machinery, okay, with myself. Okay, so N here is the 10 years. Okay, so here P is the initial cost of the equipment, N is the useful life of the equipment, and S is the scrap or salvage value after the useful life of the plant. Okay, so the straight line method is extremely simple and is easy to apply. From the graph, it is clear that the initial value of the P, here it is the initial value P of the equipment, reduces uniformly through the depreciation. Like at starting, the cost of any boiler is say 1 lakh, but after its complete usage of 30 years, its cost reduces to some 20,000, say. Okay, and similarly, like in the starting of the boiler, when the boiler is new, so very small reserve accumulation is required on its repair or maintenance, etc. But as the depreciation increases, okay, as the its use increases, the reserve accumulation required also increases. Okay, so for the reserve accumulation, you have to see from here down, from x-axis. In the starting, it is less, but as the life increases, the reserve accumulation increases. It goes on increasing, it increasing. And in the starting, the depreciation is less. So for the depreciation curve, this red line, you have to see from the top, this. Okay, in the starting, depreciation is less, but as the life increases, the depreciation also increases. It goes on increasing, it goes on increasing. Okay, so this represents your total reserve accumulation after the useful life of n years. Okay, useful life of n years. And here this value represents your salvage value, scrap value. Okay, and the total depreciation is given by P minus S. This is P, this one is S, this is P minus S is the total depreciation. Okay, so this one is the scrap value. This is the initial investment and this is the scrap value left after the useful life of any machinery. The depreciation curve PA follows a straight line path indicating constant annual depreciation charge. Okay, so this is the straight line method. A very simple formula is there, P minus S divided by N, and it is represented or explained graphically using this figure. Okay, and the next one is the sinking fund. Now let's see one numerical based upon this method first. So in this numerical, a transformer costing rupees 90,000 has a useful life of 20 years. Determine the annual depreciation charge using straight line method. Assume the salvage value of the equipment to be 10,000. Okay. So here in this question, initial investment is given, P is given 90,000, salvage value is given, that is 10,000. Okay, and N is given, that is 20 years. Useful life is given. So what is the annual depreciation reserve? So it comes out to be P minus S divided by N as per this method. Okay, as per the straight line method, it is P minus S divided by N. That is 90,000 minus 10,000 divided by 20. It comes out to be 4,000. So we have to keep aside 4,000 every year, okay, as the annual depreciation charge. Now the next method is the sinking fund method. Okay, so now let's start with the next method of depreciation to calculate the annual depreciation charge, that is the sinking fund method. Okay, and in this method, a fixed depreciation charge is made every year and interest compounded on it annually. So one another factor that is included in this method is the rate of interest. So let P is the initial value of the equipment, N is the useful life of the equipment in years, S is the salvage value after the useful life, and R is the annual rate of interest expressed as a decimal. So for according to this method, the formula to calculate the annual depreciation charge is P minus S multiplied by R divided by 1 plus R raised to power N minus 1. Okay, what is R here? R is the rate of interest. Okay, and N is the useful life of the equipment, P is the initial value of the equipment, and S is the salvage value. And the graph for this method is the like this. As in the straight line method, the graph shows you the straight lines for the depreciation and for the reserve accumulation also. Just see here. So for the straight line method, there are the straight lines for fund method. So there are slight curves are there. Okay, and this again, this red line represents the depreciation, and this green line represents you the reserve accumulation. Okay, so as with the life passes on, with the increase in the number of useful life in years, as the depreciation increases, the reserve accumulation also increases. The reserve accumulation you have to see from these x-axis, whereas the depreciation you have to see from this dotted line, this one. Okay, so in the starting, depreciation is less, so reserve accumulation is also less. But like in the middle of the life, there is some little depreciation is there, and also reserve accumulation is accordingly. But near the end of the life, okay, near the end of the life, there is large increase in the depreciation, and side by side there is a large increase in the reserve accumulation also, okay, to cover that depreciation. And the amount left after the total depreciation or after the useful life of the equipment is called as the salvage value, and this is your salvage value, or you can also say scrap value. Okay, this is the total reserve accumulation at the end of the useful life. So let's see one numerical related to this method. A distribution transformer costs rupees 2 lakh and has a useful life of 20 years. If the salvage value is rupees 10,000 and rate of annual compound interest is 8%, then calculate the amount to be saved annually for the replacement of the transformer after the end of 20 years by sinking fund value. So here P is 2 lakh, S is given 10,000, okay, N is 20 year, that is a useful life, and rate of interest is 8%, and this you have to write down in this form 0.08. Okay, now just directly applying the formula P minus S multiplied by R divided by 1 plus R raised to power N minus 1. Just put down the values and just solve it, and you got this answer. So this is how to apply the sinking fund method. Okay, now the next third method for calculating the annual depreciation charge is the fixed percentage method, or it is also called as the declining balance method or diminishing value method. Okay, so in this method, the depreciation charge is made every year at a fixed rate on the diminished value of the equipment. Okay, like in the previous two methods, the annual depreciation charge is fixed for each year. Okay, for this sinking fund method and also for the straight line method, the annual depreciation charge is fixed for each year. But for the fixed percentage method, it is different charge is there for the first year, then somewhat different charge is there for the second year, and similarly it depends upon some fixed percentage. Okay, in other words, the depreciation charge is first applied to the initial cost of the equipment and then to its diminished value, that how much the deterioration is there to that particular device, so accordingly the charge is extracted. Okay, so for this a small derivation is there. Okay, so for the fixed percentage method, let C is the initial investment, that is initial investment on any equipment or any device. Then N is the life of the equipment, useful life of the equipment. Then X is the fixed percentage of the remaining balance of initial investment. Okay, this is the fixed percentage that we have to spend after each depreciation. Okay, like annual depreciation during first year. ठीक है, like this is our initial investment, तो हम क्या मान के चल रहे हैं कि एक फिक्स परसेंटेज है x जो हम हर साल निकालेंगे एज अ डेप्रिसिएशन चार्ज. Okay, so annual depreciation during first year, so it is calculated like C, this is our initial investment, the fixed percentage of this C investment. Okay, so C multiplied by x by 100. ठीक है, why I have written here x by 100, because it is given in the question in the form of percentage, so that's why you have to divide this x by 100, so that you got the values of depreciation during first year. It is C multiplied by x by 100. So this is our the annual depreciation during the first year. Now the balance at the beginning of second year. Okay, balance at the beginning of second year. So what is the initial investment? This is C. इसमें से इतना हमने depreciation reserve निकाल दिया है. So the balance at the beginning of second year is C minus CX by 100. ठीक है. In the beginning of first year we have the amount of C, जिसमें से annual depreciation C x by 100 निकल गया. So balance at the beginning of second year comes out to be C minus C x by 100. Okay, now next step is the annual depreciation during second year. Same steps चलाएंगे. Okay, annual depreciation during second year. Now what is the balance at the beginning of second year? This one. इसका fixed percentage करना है हर साल. Okay, so it comes out to be, this can be written as C into 1 minus x by 100. It can be written like this, and the fixed percentage of this one like this. Okay, just solve it down. So this is the annual depreciation during second year, C into 1 minus x by 100 into x by 100. Now again repeating this line, balance at the beginning of third year. Balance at the beginning of third year. So what does this become? This is the balance at the beginning of second year. This is our annual depreciation during second year. And now what left? Balance at the beginning of third year comes out to be this starting amount, that is C into 1 minus X by 100 minus this depreciation. Okay, so that is C into 1 minus X by 100 into X by 100. Okay, like this. So this is our amount at the beginning of second year and this is the depreciation during second year. इन दोनों को subtract कर दोगे and that will act as the balance at the beginning of third year. Okay, so after solving it, just you see the C1 minus X by 100 and C1 minus X by 100 is common between them and I am taking them out. C into 1 minus X by 100. So what is left? Here it is 1 and here it is minus X by 100. Okay, or you can more simplify it, 1 minus X by 100 square, like this. Okay, so we are trying to derive some common formula for this. Now again repeating one more step. Now applying this step. Now this is the balance at the beginning of third year. Okay, now annual depreciation during third year. Annual depreciation during third year. Okay, and this is equal to a fixed percentage of the balance at the beginning of third year. Okay, this is our balance at the beginning of third year, that is C into 1 minus X by 100 square, the fixed percentage of this balance. So multiply it with X by 100. This is our fixed percentage that we have assumed in the starting. So now balance at the beginning of fourth year. Now balance at the beginning of fourth year. Balance at the beginning of fourth year. So what is it? This is the balance at the beginning of third year. This is our annual depreciation. Just subtract them. Okay, as we done in the previous steps. So just subtract them. So it comes out to be this one, C into 1 minus X by 100 square minus this factor C into 1 minus X by 100 square into X by 100, like this. Okay, we are just subtracting the balance at the beginning of third year and annual depreciation during third year. Okay, so when you are going to simplify it, just take this term common, C into 1 minus X by 100 square, C into 1 minus X by 100 square. Just take them common. C into 1 minus X by 100 square. So what is in the bracket now? Here it is 1 and here it is X by 100. 1 minus X by 100. Okay, and just more simplification, C into 1 minus X by 100 cube. Okay, now just note down one thing, that the balance at the beginning of fourth year, what is the formula? C into 1 minus X by 100 cube. Okay, balance at the beginning of third year, the formula is C into 1 minus X by 100 square. Okay, so what is our useful life? Our useful life is N. Okay, now I am going to write one generalized formula for this, like balance, just I am writing here, therefore similarly balance at the beginning of, if there is fourth year, then the formula has power of 3. Okay. And if there is third year, then the formula has power of square. Okay. So I am going to write down here balance at the beginning of n plus 1th year. We know that the useful life of the equipment is n, but I am going to write here balance at the beginning of n plus 1th year, and this balance is same. It is also equal to balance at the end of nth year. Okay, this one is same. Okay, or balance at the beginning of n plus 1th year is equal to the balance at the end of nth year. Or you can also say like that, the balance at the beginning of 4th year is same as the balance at the end of 3rd year. Okay, similarly, balance at the beginning of 3rd year is same as the balance at the end of 2nd year. Okay, but here we want our life of n years, so that's why I have written like this. Balance at the beginning of n plus 1th year is equal to the balance at the end of nth year, and the formula now comes out to be C into 1 minus x by 100 raised to power n, because for n plus 1th year the formula gives you here n. Okay, as here for the beginning of 4th year the formula gives the power of 3. Okay, for the beginning of 3rd year the formula gives the power of 2. Okay, similarly for the beginning of n plus 1th year the formula gives the power of n. And how much amount is left after the useful life? We called that amount as the salvage value. Okay, after the useful life of the equipment is finished, the amount left for that equipment is called as the salvage value. Okay, and so this is equal to S. Okay, that is the salvage value. So the complete formula is, so this is equal to salvage value. So this is the formula that have been derived using fixed percentage method, that the salvage value is equal to C into 1 minus x by 100 raised to power n, where C is the initial investment, n is the useful life of the equipment, S is the salvage value, and x is the fixed percentage of the that is kept aside in after each year. Okay, so this is the formula, and in some numericals they said to calculate the value at the end of say 4th year. Okay, so at the end of 4th year then you directly apply here n is equal to 4. Okay, and if they said to calculate the value or amount at the beginning of 5th year, so for the beginning of 5th year, then you have to see the word that is beginning. So for beginning, again you have to apply n is equals to 4. If they said end, then apply the same figure. Okay, so this is the net formula for the fixed percentage method. Okay, so as per the PPT, so this is the capital investment, useful life, salvage value. So the value of the equipment after 1 year, so P minus P times X. So it will give the same formula P into 1 minus X. Here they are using simply X. Okay, as we have done on the board, they are using X by 100. Okay, they are using here simply X. So the value of the equipment after 2 years, that is the diminished value P minus Px, and minus time the fixed percentage of next one. Okay, so this is the net result S, that is the salvage value, comes out to be P into 1 minus X raised to power N. This is the same formula that we have recently derived on the board. And from here, if you want to calculate X, that what is the fixed percentage? What is the value of that X? So simply divide first S by P, then just shift this raised to power N to this side, 1 by N, and X comes out to be 1 minus S by P raised to power 1 by N. Okay, so like this. Similarly, the annual depreciation charge for the subsequent years can be calculated, and this method is more rational than the straight line method. More accuracy is there. The initial value P of the equipment reduces through depreciation to the scrap value S over the useful life of the equipment. So as the life goes on, as the life passes on, the cost of that particular machinery reduces to salvage value. Okay, initial is P, and the net after n years it reduces to S, that is the salvage value. Okay. Now let's see this numerical, and here it is solved by using all the three methods. So the equipment in a power station costs rupees 1,560,000 and has a salvage value of 60,000 at the end of 25 years. Determine the depreciated value of the equipment at the end of 20 years on the following methods: straight line method, then diminishing value method, the same one, that is a fixed percentage method, and then the sinking fund method at 5% compound interest rate. Okay, so for the straight line method, we know the formula is P minus S raised to divided by N. So this is our P, this one is S, divided by useful life 25 years. Just solve it and you got this result. Okay, so the value of the equipment after 20 years. Okay, if you want to calculate the value after 20 years, so it comes out to be P minus annual depreciation. This is annual depreciation multiplied by 20. So 1,560,000 minus 60,000. Here we are calculated multiplied by 20. Okay, so this is the result. Then in the diminishing value method, annual unit depreciation. Now in this first, X is not given. Okay, so calculate the value of X first. That is 1 minus S by P raised to power 1 by N. S is given, P is given, N is given, and just solve it on the calculators and you got this result. Okay, now the value of the equipment after 20 years. Okay, so after 20 years, that means at the end of 20 years, so it comes out to be P into 1 minus X raised to power 20. Okay, here you have not to take 25. You have to take here 20. Just put down the value of P. Now X is 0.122 and raised to power this 20 and you got this result. Okay, and similarly in the sinking fund method, this is the formula P minus S multiplied by R into R divided by 1 plus R raised to power N minus 1. So just put down the values and you got this result. So sinking fund at the end of 20 years, now put here N as 20 and you got this result. Okay, so the value of plant after 20 years comes out to be, this is the initial minus this cost, you got this one. So these are the type of numericals that are based upon this depreciation methods. So this is one more numerical for your practice only. So here the steam power plant is erected at a cost of this. This is the initial cost or initial investment. Salvage value of 15%. Here the salvage value is not directly given. They said it is 15%. 15% of what? This initial investment. So first calculate the salvage value. Okay, useful life is given 25 years. Interest rate is given 8%, and now find the annual depreciation reserve. Firstly for the straight line method, then sinking fund method, and then the fixed percentage method. For the fixed percentage method, firstly you have to calculate X, that how much fixed percentage is there. So for X, you have to apply this formula. This X is equals to 1 minus S by P raised to power 1 by N. So by using this formula, first calculate X, then do the final calculation. Okay. So this numerical is for your practice. And now this last topic, effect of load factor on the cost of energy. The load factor plays a vital role in determining the cost of energy. So some important advantages of high load factor. So high load factor, the first advantage is reduces the cost per unit generated. Okay, so what does we conclude that as the load factor increases, the cost of energy decreases. Okay, a high load factor reduces the overall cost per unit generated. The higher the load factor, lower is the generation cost. It is because higher load factor means that for a given maximum demand, the number of units generated is more. So this reduces the cost of generation. Okay. So with the increase in the load factor, the cost per unit generated is decreased. Cost per unit. Okay. Not the overall cost, cost per unit generated. And what is the second advantage? It is reduces the variable load problems. A high load factor also reduces the variable load problems on the power station. A higher load factor means comparatively less variations in the load demands at various times. Okay, this avoids the frequent use of regulating devices installed to meet the variable load on the station. Okay, so as the load factor increases, the variable load problems also reduces. Okay, so these are the main advantages, or you say the effect of load factor on the cost of energy. Okay, so now let's do one numerical. And in this numerical, what is given? UC is the unit capital cost. Unit capital cost, it is given rupees 18,000 per kilowatt. Then fixed charge rate. Fixed charge rate is given, it is 10%. Then capacity factor is given 0.55. Fuel consumption 0.7 kg per kilowatt hour. Then fuel cost is given rupees 1500 per 1000 kg. Then other repair and maintenance cost related to the operating cost, it is given 20% of annual fuel cost. Then utilization factor is given 1. And apart from this, the capacity of the power plant, it is given that 110 megawatt. Capacity of power plant, it is given 110 megawatt. And you have to calculate the generation cost. Okay, so you have to calculate the generation cost. So what is the generation cost? We know that the generation cost is equal to annual plant cost divided by the energy generated. Okay, so firstly we have to calculate the energy and then the annual plant cost. So in this numerical, we have to calculate the generation cost. So firstly, we have calculated energy by using this formula, that is capacity multiplied by capacity factor into 8760. That is the total number of hours in a year. Just putting values, capacity it is given 110 megawatt, but all our rest units are in the kilos. So that's why we are using here 110 into 10 raised to power 3 multiplied by 0.55 is given, multiplied by 8760. So this is the answer in kilowatt hour. Just remember to put down the units. Okay. Now next, annual fixed cost. The formula is unit capital cost multiplied by the fixed charge rate multiplied by capacity. So UC is given in the question rupees 18,000 multiplied by fixed charge rate is 10%. So it is written 10 by 100. Capacity is again 110 into 10 raised to power 3. Just solving, and this one is the answer for annual fixed cost. Then fuel consumption, it is given 0.7 kg per kilowatt hour. ठीक है, it is per kilowatt hour, so we have to multiply 0.7 multiplied by the energy. So 52998.10 into 10 raised to power 4, this one, and this is the total fuel consumption in kg. Now the fuel cost is given in the question as rupees 1500 per 1000 kg. So multiply the consumption. This is the total consumption in kgs with 1500 divided by 1000. Okay, so this is the net fuel cost. Now other maintenance and supplies repair cost, that is given as 20% of annual fuel cost. So it is a 20% of this fuel cost. So this is the answer. And now the net operating cost comes out to be fuel cost plus this one, other maintenance and repair cost. So just add both of them. So you got this result as the annual operating cost. Okay, now the annual plant cost. Annual plant cost is annual fixed cost plus annual operating cost. So this is our fixed cost that we have calculated here. Operating cost, this one. So just put them and add them. So this is your annual plant cost. Now finally, to calculate the generation cost, the formula for generation cost is annual plant cost divided by energy, and this is the answer, that is rupees 1.6336 per kilowatt hour. Units are rupees per kilowatt hour. So this is our numerical related to the different costs of the power plant: fixed cost, operating cost, then plant cost, then generation cost. Okay, so this is all about in this chapter. Thank you.